Hi, this is Pedram from PhysicsAcademy.com. Today we're going to work through a forces kinematic combined practice problem. Let's read and analyze this problem together. So the weight of the person in Newton is given. Starting from rest is a keyword to say the initial velocity is 0. The depth of the cave or well is 40 meters. The maximum tension force the rope can handle is 600 newtons. We're asked to calculate if we pull this person out over 10 seconds, the tension force stays below the threshold of 600 newtons or not. Alright, let's start with sketching the side view of the problem statement. The well is 40 meters deep. I keep the positive direction of the y-axis upward. Keywords like time, 40 meters, and initial velocity of 0 all tell me that we will deal with time-dependent kinematic equation here. Let me write it down. Remember, a, or acceleration along the y-axis, is the total, also known as net, acceleration of the object along the y-axis. By object here, we mean the person, just in case. This is a common practice in physics to consider everything as an object. Okay, assuming the initial velocity is 0, we can simplify and rearrange this equation to find the total net acceleration of the system. After plugging the values and their units, we get 0.8 meters per second squared. Alright, let's sketch the free body diagram of the system. Remember, in an FBD, we need to draw our coordinate system, add our target object like a little dot at the center, and then add all of the forces acting on this object. Here we don't know the mass of the person in kilogram. So I'm going to convert that 5.3 times 10 to the 2 to kilogram by dividing it by g, the Earth's gravitational acceleration, 9.8 meters per second squared. Alright, so the weight of the person is 530 divided by 9.8 kilogram. Let's write Newton's second law equation here. On the left-hand side, we have all of our forces. As a side note, you see how I keep all of my forces in an absolute value form instead, and I pick the signs based on our coordinate system. I know F gravity is negative along the y-axis, so I have a negative sign for it. Also, as you see, F tension is toward the positive direction of the y-axis, so I have a positive sign for it. The right-hand side of this equation is the object's mass and total net acceleration along the y-axis. Remember earlier we calculated this mass and its total net acceleration. So the right hand side is all set. F gravity is given 530 newtons. So let's see what F tension under this condition is. All right, as you see, the tension force is about 573.265 newtons, which is less than the threshold of 600 newtons. So we're good, and pulling the person out over 10 seconds is doable. Thank you for watching my step-by-step video. If you liked it, consider subscribing to my channel. This is the best way to support my work here. For more practice problems, you can check my website, physacademy.com, and have a good day.